leading edge segment to check system installation on the wing. What have we achieved? We could achieve to modify an existing A320 VTP and conducted during April and May 2018 a flight test with a simplified HLFC system, where this success is really should be highlighted here, as this was the first time in Europe this kind of system has been flown and tested successfully. In addition, and having a look on the wing, we tested in March 2018 a ground-based demonstrator representing a wing leading edge, and we conducted an icing wind tunnel test to test the sled system and the wing anti-ice protection system in Cira premises in Italy. This is just the pure result, but we have of course always what we call, or what I call, spin-off and acquire.
Dear participants of the 32nd ICAS Congress in Shanghai, China in 2021, we all know that due to COVID-19, we are not able to be on site in Shanghai, so we have to do this remotely. But nevertheless, I have a great pleasure to present to you the ICAS von Karman Award of 2021. My name is Roland Gerhards. I'm member of the Executive Committee of ICAS as a part-time job. As a full-time job, I'm the CEO of the ZAL, the Center of Applied Aeronautical Research in Hamburg, Germany. This year, we have a very special situation. We all know that. But still, we have very, very good awards we present to you. Pre-recorded, but nevertheless, very proudly presenting these awards. This is the ICAS von Karman Award. Its purpose is to acknowledge exceptional achievement in international cooperation, which is a key element of ICAS, in the field of aeronautics, being awarded to a project or program in which 2 or more countries are major participants and which is characterized by substantial technical achievement, scientific or technological advance, or benefit to society. This is the background of the ICAS von Karman Award. This year, we present this to AFLONEX, which is really, really a key project supporting all of these underlying ideas of the ICAS von Karman Award. This project is truly international. AFLONEX has participants from more than 40 partners from 15 European countries. It was a 5-year program funded by the European Union. It has delivered outstanding results in the field of flow control technologies. I will come back to that a little bit later, for novel aircraft configurations. By maturing key technologies that have the potential to significantly reduce the environmental footprint of large passenger aircraft operations, the European aeronautics industry will reap benefits from this project for decades to come, helping to secure its leading position in the global aviation industry. The project the name is AFLONEX. It stands for Active Flow, Loads and Noise Control on Next Generation Wing. It has a budget of more than 37 million euros, including nearly 24 million euros of funding. It has 7 work packages, 6 technology streams consisting of hybrid laminar flow technologies, of flow control, and of noise and vibration reduction, which are all key elements of reducing the environmental footprint of aviation, either through reducing the drag, reducing the weight, or reducing the noise, all having an environmental impact on the public. M.Wahlich will present more details on this in his lecture, which is coming up shortly. But two key points I would like to mention as well. A flight test aircraft, an A340, flew in the second quarter of 2018, which is really a large-scale demonstrator. It couldn't be any larger, I have to admit. And several wind tunnels were included in this project as well, like Zagi, the DLR, and DNW wind tunnels. And the project partners are truly European. We have partners from Germany, of course. We have partners from France, Spain, UK, the Netherlands, Belgium, Italy, in reaching out to Russia, to Israel, and Turkey. So really a European project, more to mention as well, like I think Sweden and Finland are partners here as well. So it's really a European project, and I'm really proud to present now the award and the medal to M.Wahlich, who is the representative of this project. He was a project lead. I will shortly introduce him to you. He represents the whole project with 40 different partners from 15 countries, as already mentioned. He personally graduated in Bremen with a degree in mechanical engineering. He started his professional career in the automotive industry almost 20 years ago in the field of strategic planning for passenger cars. In 2000, he entered the flight physics department of Airbus, and he contributed in the field of experimental aerodynamics in almost all Airbus aircraft programs and in several research projects. So he is the organizer, the leader, the manager of this project, and he receives this award representing all participants here from all the different partners here. So, M.Wahlich, welcome on stage.
Thank you. Thanks a lot.
Welcome here in Hamburg. And I would like to hand over now the prize to you. This is the writing of all the content. What is the von Karman Award, and the AfloNext program is briefly described. So thank you for your contribution.
Thanks a lot.
And congratulations to this award. And in addition to just this document, we have the von Karman medal, which is really heavy, I have to admit. And I hope that we can show this now, that you can show this to all the participants in the program, because it's really a valuable recognition of the contribution of all the different partners here.
Thanks a lot.
Congratulations again.
Thanks a lot. I feel very honored, and thanks a lot for the complete AfloNext consortium, because I'm just the representative, but it's a prize for all contributing members, and so I'm very proud of this acknowledgement by ICAS.
Yeah, you're more than welcome. And from what I've seen from this project is really, really in the sense of the von Karman Award with the international collaboration, which is really was part of this project here. So
thanks a lot.
Oh,
it's really heavy, yeah? It's really heavy. So, I will just make it like this.
Okay. So we have everything on camera. So we all say hi to Shanghai, to the Congress, and hope to see you in person then the year after at the next Congress in Stockholm then. So see you all soon.
Yeah.
Bye-bye.
Thanks a lot. Bye-bye.
Hello, my name is M.Wahlich from Airbus Operations, and today I will deliver the von Karman lecture about active flow loads and noise control on next generation aircraft, project abbreviation AfloNext. And this is the outline of my presentation. So I will give you a short motivational introduction why we have done AfloNext. About the project setup, I will drop some words and the objectives. I will show you the main achievements, and finally a conclusion and an outlook. Well, despite the COVID-19 crisis, which is still ongoing, we will face a significant increase in aviation traffic. And this makes it inevitable to reduce ecological footprint of passenger aircraft. And here AfloNext is tackling 4 key topics leading to more environmental friendly aircrafts. So first, we have one major pillar which tackles and which deals with laminarity in order to reduce drag, and finally the fuel burn of aircrafts. We have active flow control here, especially on local applications, to increase aerodynamic performance during takeoff, during landing, and to allow installation of more efficient engines. We have passive noise control, as noise is a significant environmental factor of aircrafts. And we have vibration control and mitigation in order to allow a design of an optimized airframe components in order to reduce overall aircraft weight. So let me talk a little bit about the project setup and the detailed objectives. Well, this is the statistics. Very bluntly speaking, it's 40 partners, 15 countries. We have a total budget of 37 million euros in total, where we received effectively nearly 24 million euros effective funding from the European Union. Project duration was 5 years. We started in 2013 and we ended in 2018. So this is just the pure figures, but just let me show you the landscape of our partners, which is for me rather impressive. You see, we are spread all, or we were spread all over Europe in 40. We had 40 partners, 15 countries, and the budget figures are already mentioned. As you can see, we as well had Russia, Israel, and Turkey as associated members as well. Okay, the general objectives. The general objectives of Aflonex are quite clear. We wanted to mature promising flow control technologies up to very high maturity levels. That means TRL5 and maybe TL4 up to TL5, and then hand them over in large-scale demonstrators, such as, for example, what you can find in Clean Sky 2. Here again, the 3 pillars I've mentioned, the 4 pillars I've mentioned before. This is hybrid laminar flow control for drag reduction. We have active flow control, passive vibration, and noise control technologies. In order to visualize the more detailed technology streams we have in Aflonex, I will give you here a brief overview. So when we talk about hybrid laminar flow control, we want to apply it on the VTP and on the wing. And this could lead, if you apply hybrid laminar flow control on a complete aircraft, this could lead up to 9% fuel saving approximately. Then we have the areas where we wanted to apply the active flow control principles on local applications. So we did it on the outer wing in order to allow a more aggressive design of a wingtip. We applied it on the pylon wing junction. Here, active flow control could act as an enabler to install a new generation of engines, namely UHBR engines, which are in diameter much more larger than the conventional ones. And we have as well active flow control on the trailing edge in order to increase high lift performance. And in total, you see the figures, we could as well gain up to 4% in total of fuel saving if applied properly. Then we have the noise control area, and here we focused on the interaction of flap and main landing gear. And finally, we had investigations on vibration, mitigation, and control on the undercarriage area in order to allow new design principles of these kind of components. Okay, this was the setup And now I will show you again the major objectives and show you the achievement of each techno stream I've shown before. So we start with hybrid laminar flow control. So here the main objective, as said, implementation on an VTP and implementation on a wing. So main objective finally was to have a flight test demonstration on a VTP and to build a ground-based demonstrator, sorry for this, on a leading edge segment to check system installation on the wing. What have we achieved? We could achieve to modify an existing A320 VTP and conducted during April and May 2018 a flight test with a simplified HLFC system, where this success is really should be highlighted here, as this was the first time in Europe this kind of system has been flown and tested successfully. In addition, and having a look on the wing, we tested in March 2018 a ground-based demonstrator representing a wing leading edge, and we conducted an icing wind tunnel test to test the sled system and the wing anti-ice protection system in Chira premises in Italy. This is just the pure results, but we have of course always what we call, or what I call, spin-off and acquired knowledge besides these project successes. And if you look on the acquired knowledge and spin-offs, what have we learned in addition, or what comes along with this? This is really, we could prove design and manufacturing methods for HLFC purposes, including the validation of our numerical prediction methods across Europe, which is really a success. We developed and built and tested successfully and validated successfully an in-flight monitoring system for the flight test aircraft to have an online measurement or an online evaluation of the laminarity achieved on the VDP during flight. And looking more on the wing side, we could install, or we could achieve, several different layouts for HLFC integration on a wing on aircraft design. Okay, this was the HLFC part. Now coming to the active flow control part. Here I would say two major objectives we followed. This is first, we want to have a wind tunnel testing of different active flow control system. Here a full scale wind tunnel testing, that means nearly one-to-one scale wind tunnel model. And we want to develop and integrate different active flow control systems for the wing. So here, what was very successful, we tested a nearly full-scale wind tunnel model at Zagi premises, where we could really show the potential of active flow control on the pylon wing junction in order to recover lift lost due to UHBR installation. In addition to this, several HLFC systems for the outer wing have been designed, built and tested. And here we could really show that HLFC could be a potential enabler for more aggressive outer wing design. So that means you have, you will be able to overcome flow separation on the outer wing induced by winglet design. Here HLFC, here active flow control could help to give more aggressive wingtip design. And again, the slide, what were the spin-offs and acquired knowledge? During the complete work package, several different kind of actuator principles have been designed and tested. So I just show you the abbreviations because to show the deep technical principles, it will, let's say, burst this presentation. So we have a pulse jet actuator, we have synthetic jet actuators, we have a hybrid version of both. We developed active flow control actuators as a tile inserted in the surface of a wing, and so on. Here, by designing on the one part the hardware as well, we could validate and benchmark several different CFD methods with respect to this active flow control simulation, which is really a step forward to this kind of simulation and to this kind of design into the aircraft process. Okay. The third major pillar was really the noise reduction. As said, noise reduction is really important for the environmental footprint of an aircraft. It's not only fuel burn, as well noise reduction. And here, as said, we concentrated really on the flap and main landing gear area. Here we designed, tested several kinds of noise reduction devices. When I said tested, we performed a flight test with, on the one hand, with a porous flap side edge, what we call like this. So you take a porous material on the outer flap side edge and measure the noise impact of this kind of device. Not in Aflonex, but in an DLR own program, we developed together with LN Atra several noise reduction devices, mainly for the landing gear. So as you see on the right hand, it's torque link mesh fairing, we have new kind of leg door fairings, and we have some brake covers. And this has been successfully demonstrated, and the full potential of these kind of noise reduction devices have been shown. So this is the noise reduction part. And as well, same principle, what kind of spin-off and achievements, especially the porous flap side edge, could be directly applied for the aircraft manufacturer. This is possible. So here we really reached a very high TRL. And as well and especially as for the other shown parts, we made use of new manufacturing methods here, namely additive layer manufacturing, so or rapid prototyping, as you like. This was really very, very successful. Last but not least, I come to a work package which is a little bit different from the other ones, as we are here dealing more on the structural side, not on the aerodynamic side. So about vibration mitigation and control, what were the main objectives? The main objective was to develop a numerical method for simulation of these phenomena I will show you later on. In addition to this, and deriving from this simulation methods, new types of devices for reducing vibrations level have been designed and validated during flight tests. When I said validated, was the validation of the numerical methods in combination with the hardware being built. So here's the main problem you see. It's that some wakes coming from the nose landing gear will hit the main landing gear doors and causing a lot of vibrations and might cause structural fatigue. For the time being, these kind of phenomena was not properly modeled in a numerical process, and here we could combine an structural and aeroelastic coupling. This was the major outcome of Aflonex. In addition to this, we thought, okay, how can we reduce these kind of vibrations? And here we had a dual approach. One, we did, let's say, mechanical devices to reduce the vibrations, tuned mass dampers, and we had aerodynamic devices who influence the vortexes in order to reduce the vibration level. Okay, both systems has been tested and successfully validated during a flight test conducted as well in April and May 2018. Again, the same methodology. What kind of spin-off and acquired knowledge? Well, especially for the nose landing gear door, we developed, or a new method for manufacturing was developed in order to have a monolithic nose landing gear door. We could develop devices which could be used directly for the aircraft manufacturer, especially what I saw, vortex generators, spoilers, and on the main landing gear door. So these means could be directly implemented on an aircraft. And I think this is the major point. We could validate different CFD methods and codes. Weiter. Okay, this was the technical part of Aflonex. And now what is the conclusion? What is the outlook? So first, let's start with the outlook. As mentioned, Aflonex, or the technologies we have developed in Aflonex, should be handed over to a larger research program in order for further maturation. Here, as an example, I used Clean Sky, and I will go through each techno pillar and tell you what is, let's say, the outcome, what are we working on at the moment. So about HLF, hybrid laminar flow control, HLFC. Here, within the frame of large passenger aircraft, we have a large work package in Clean Sky 2 called hybrid laminar flow control and advanced laminarity. We focus on the one hand on the HDP and on the wing. HDP is for manufacturing processes for serial application, and the wing is to simplify the HLFC system for a better integration on the wing. Here, clearly to say, Aflonex was, let's say, one foundation brick, delivered the results enabling these work packages. With respect to active flow control, we have as well active flow control set up on active flow control work package in Clean Sky 2, especially with respect for the ultra-high bypass ratio engines. So the UHBR integration is not strongly relying on it, but active flow control set, as said, is an enabler to this. So here as well, Aflonex could deliver really very valuable results for further maturation in Clean Sky 2. About the vibration mitigation and noise control on airframe, there is no continuation in Clean Sky 2. As very simple said, we could use it directly on the aircraft. There is no need for further maturation in the frame of a really large R&T program. So as well, in Clean Sky 2, we are building large demonstrators. The next step could be clean aviation. Then the successor of Clean Sky 2 is rising on the horizon. It's getting more and more mature. And we hope to get some input from Clean Sky 2, which could be directly linked to the Aflonex outcome for in-flight applications. This is the outlook. If I look on the conclusion, we could really saw a very strong engagement from the participants, which has always been visible. And now I'm striving a little bit away from the technical side, going more on the collaboration side. There was never any retreat from a partner, or partners refuse to work on it because they are short of budget, short of resources. If problems encountered, we could always solve. As shown, all major objectives of AFLONEX have been achieved. As shown as well, AFLONEX could contribute to reduce overall ecological footprint of a passenger aircraft if these technologies would be applied on new aircraft designs. And we achieved outstanding technical results as well. This is the link to the main objectives, which is really the foundation of several actual and future research activities. And as said, and already partly done, it's a handover of these kind of technologies we have developed in AFLONEX to further mature them and really make these technologies available for the next generation aircraft in the next decades. So thanks a lot for your attention, but I have some final closing words. The von Karman Award is for international collaboration in aviation industry. And so the question is, what is a project? And I like these PMI definition. Project is a temporary endeavor undertaken to create a unique product, service, or result. And this is really what AFLONEX has done. We had an endeavor which was challenging, which was bonding people together, and we created unique product as a result. It was a journey, a kind of journey we have undertaken over the 5 years between 2013 and 2018. And this is just a picture of the Mount Everest. And I like always to compare this kind of collaboration with, let's say, climbing up or conquering such a high mountain. When we start in 2013, here you see the people, the foundation people. When we had our first kickoff meeting, we set the ground rules. 1 year later, we met in Tel Aviv to get, let's say, the first impression of is the foundation correctly. We presented in front of the European Union and got, let's say, confirmation that we are on the right track. 1 year later, of course, we had an annual review meeting in Warsaw, which shows more and more maturity on each techno pillars. In June 2016, we met at Chira in Capua. And here you really could see first mature results, but you could see as well obstacles to overcome. Not everything is a smooth paved way where it's not always an easy journey. And as you could see, maybe if you read carefully, we have a 1 year break between June 2016 and May 2018, where we had the final ARM, because the route was not as straight as it is shown on the picture. It was a little bit like this. So we had to stop a little bit, we had to slow down a little bit, and then we had to ramp up, especially for the demonstrator testing, for the flight tests, and for the wind tunnel tests. And finally, we could really achieve all the results. What I wanted to say with this is, people make the difference here, and outstanding team collaboration. When you imagine you have 40 partners, 15 nations, this was outstanding, and here I really would like to thank the ICAS for acknowledging this contribution of all the partners for AFLONEX. I'm really proud to receive this award on behalf of the AFLONEX consortium, and I think we can all be very proud of this achievement. Thanks a lot, and have a good day. Bye-bye from Bremen and from Hamburg.
Yeah. So thank you very much. Ooh, the sound is really bad now. We are sorry for this for the bad sound at the beginning. I hope that everything runs smoothly on right now. Hope that you could follow the very nice presentation from Martin. So Martin, congratulations again to your project success. It's really an impressive project, and the last picture was really wonderful with climbing a mountain together. It's really, I just read the comments here. It's really a challenge to lead such a project, but it's also the international spirit, the collaboration spirit, which we could see here, which is especially exactly in the frame of ICAS as well. International collaboration in research is our key topic, and it's wonderful to see how you really did this with AFLONEXT, with the AFLONEXT program, and meeting people from other countries, working with them together is really a unique opportunity, something I like personally very much as well. So thank you again for your presentation. And congratulations to your award. Well received award, and congratulations to the complete team. I hope that you could celebrate a little bit the award, and that you could somehow distribute the remarks to the complete team here. So we are now open for questions. We have a couple of minutes left for Q&A, so feel free to write any questions in the chat function. Martin, I would like to start with a couple of questions from my side before other questions might roll in. And that is something about the outlook. You know that I'm running the Center of Applied Aeronautical Research, and I get a lot of questions from companies, from partners. When do we apply things on real aircraft? And there are two things I would like to discuss a little bit with you. One is the hybrid laminar flow. When do you think we're going to see that really on a production aircraft? What do you see before we see that integration? And especially when I worked at an OEM, we had a lot of discussions about the system integration. So not only the aerodynamical effects, but also the system integration for hybrid laminar flow. Did you discuss that as well, or what is your opinion on that?
Okay, so as you mentioned correctly, I think the aerodynamics is a one part, and I think aerodynamics of laminarity, either if it is natural laminar flow or hybrid laminar flow, is quite well known and quite well, let's say, the tools are as sharp as they could now as they could be in order to design. But the major challenge is really to integrate it into a wing. And here, let's say one part is system integration, and this is exactly tackled in Clean Sky 2. The other part of hybrid laminar flow control or laminarity application as well is, of course, manufacturing technology. It has been shown as well in AFLONEX, we had to overcome some obstacles for the flight test, and especially if you do something like an add-on on an existing design. So if you want to integrate hybrid laminar flow control correctly or laminarity correctly, you have to start it right from the scratch. When you design a wing, and a VTP and HTP, whatever, you have to made it for this purpose. And I think this is, let's say, setting a little bit the scene about integration of future aircrafts. If there is a business case visible, I think it will be integrated in, I would say, earliest in long-range aircrafts, because I think, is it sufficient?
Yeah, that's fine. I mean, we did some calculations about all the snowball effects. So if you're flying Atlantic routes, for example, with laminar flow, if you have a system failure, you reduce the fuel load if you save fuel, so you're relying on the system. So what happens if the system fails is a big question there. So to catch all the snowball effects, which are then really give effect of an overall fuel consumption, is really important from my point of view. And for that, you need a high availability of system integration. And manufacturing is always a big issue. Did you find solutions for that, or is Clean Sky defining solutions for manufacturing? Is it also with additive manufacturing, or what are the ideas behind that?
I think Clean Sky, in Clean Sky 2, we are very, very focused on manufacturing technologies and on simplification of the system, because at the end, for an aircraft manufacturer and an aircraft operator, finally it has to pay off. You can have the nicest aerodynamic solution available. If it is too complex, too expensive in daily use, and here it's really the key challenge in Clean Sky 2 to get to simplify systems. I think this is really the key here.
Mm-hmm. Yeah, interesting. Thank you. I have another question, but before we come to that one, we have a question from the audience. Gunnar Holmberg from Saab. Hi, Gunnar. Thank you for your question. You described the climbing of the Mount Everest, but isn't it most dangerous and difficult to get down? How does your analogy work there? So you climbed the hill together. What happened after the final meeting, the final team meeting? What happens with the team? How did you get down? What you described the next steps with Clean Sky, but what happened to the team and how did you manage that aspect? So good question, Gunnar. Thank you very much.
Okay, thanks a lot for this question. Well, the world let's say, the people working in this kind of environment with the shown techno pillars is rather small in Europe. So we meet a lot of people met again within the frame of Clean Sky 2, and this is I try to show and to reflect on the page with the outlook. So of course, there was dissemination events, and we did conferences and workshops, but the application afterwards with the people was really that we met it was a foundation of Clean Sky 2 in a way, of the work package you see, and there you meet these people who are working in Aflonex. You will find a lot of them and a lot of these facilities and partners again in Clean Sky 2. And as well, furthermore, next step is actually clean aviation, to ramp up clean aviation. And here you see as well, for these kind of topics, the partners you will meet again.
You're still in contact with the 40 different partners, so you still know them. You're still in contact with them. Some of them, most of them.
With some of them, not with all of them. 40 partners, to keep the complete contact of to 40 partners is rather difficult, but with, let's say, the really main ones, we are still in contact, and there was a strong trust we built up in Aflonex. There is still these kind of trust. If you talk to them and try to get future projects done or elaborate possible ideas, it's still there.
Mm-hmm. So did you write the application for Clean Sky 2 then together with the team, or the sketches and proposals? Did you define them in the project?
I didn't get it acoustically. Did I what?
Did you write the sketches and proposals for the new Clean Sky projects within this project? So did you write the sketches? So
no, it was not within the project. It was not within Aflonex. It was not within Aflonex. But as you could see, if you look a little bit on the time scale, Clean Sky 2, for example, Clean Sky 2 was ramped up in parallel to Aflonex, and there, of course, we had a look. Okay, what could be the results of Aflonex? How could we use these kind of results in Clean Sky 2. And therefore, we did not write the proposal, but we could, let's say, a little bit influence the way these proposals could do and to make the best exploitation of Aflonex results.
Yeah. So we have another question, and exactly my second question. So Sebastian Remy, former Airbus. Sebastian, you're covering exactly my second question. Thank you for posing that. The current fleet of commercial aircraft will keep on flying for decades. I mean, we know that lifespan of an aircraft 30 years, more than 30 years. So we have a lot of aircraft flying for a long time. In your work, how do you investigate retrofitability of applicable solutions? And retrofits was exactly my question. My question was concerning noise, because that could be really a quick win. And from what you've shown, there were already solutions which you can produce. So you were on a high TRL, you said. Is there a possibility to retrofit old aircraft, currently flying aircraft, to reduce noise on these? And maybe not only noise. I mean, of course, we lose the snowball effects of laminar flow, but isn't there a possibility for noise and maybe some other solutions to retrofit them on the current flying aircraft?
Well, for noise and vibration, a clear yes. For active flow control and laminarity, it's a maybe, because the system complexity of these systems are much more higher than the solutions we have found for noise and vibration. And therefore, as said before, some things you could retrofit, but you will not gain the benefit you would like to expect to realize a proper business case. And therefore, it's regarded, but it was not part, in the way it was not part of Aflonex to get the maturity as high as, for example, to TRL6. This was just the outcome. I would say it was lucky circumstances in two pillars, but for active flow control and laminarity, we were at the level of TRL4, TRL5, and therefore, the retrofitability of these complex technologies is up to other projects and programs.
And concerning that question, what is the share of intellectual property between the different partners? Because it was not only, I mean, you're from Airbus, we know that, but several using or contributing a lot of stuff, and these are not only universities, but they are companies. Maybe are they interested in offering retrofit solutions on their behalf? Is that possible? Can they take that out? How do you deal with intellectual property rights in this project? Do the partners own the complete outcome, and can they work on their own behalf of that, of offering, for example, Safran offering retrofit solutions, or is that not possible?
The diplomatic answer is it depends. Of course, it depends. Of course, we have a consortium agreement in place. It's still the contractual framework is still active for Aflonex, and it is defined, and it strongly, of course, depends on which technology you are talking about. And then, but here I can't go any deeper. This is really at the end it will come up to negotiation between partners. That's it. This is all I want to say about this.
I know that this is a challenge, and this is a question I get all the time in our tech center, to see who then uses the intellectual property on their behalf. But I fully agree with you. It's within the project defined, I guess, at the very beginning, so that at least what I know from all of these projects we do in our tech center as well, you define at the beginning the intellectual property right distribution, and then you discuss during the project if things change, but it's not something you discuss at the end, but it's then
and retrofitability is not often not so easy as said. Some technos I have presented here have a very high system complexity, and
We investigated as well, let's say, during the project, but as well during Airbus internally sometimes, let's say, does it pay off at the end? Because finally, if you look from the aircraft manufacturer side, the customer has to pay for it. They must be willing to pay for it, for this extra. And as well, you have to ensure that the operability of the systems is so safe that there is no disadvantage for the customer.
Yeah,
this is the next step. I think this is really the next step for the succeeding projects.
Yeah. But this is a remark I get all the time from research. As I said, applied research is our main topic here. And it's really, when do we apply the results and when do we see that? And I know all the challenges quite well. The airlines, they have to pay for it. So what is in for them if they reduce noise of the landing aircraft? Is there a reduced landing fee or something like that? So sometimes it's about regulations. Is it required or not? And if it's not required, it's not done. It adds cost for the benefit of something else, just noise or reduced fuel consumption. Does it pay off in the long run for the airlines? We've seen it with the Sharklet, where things turned out quite smoothly and well for everybody involved, for Airbus producing them, for the airlines operating them. So there's a clear benefit, and this is what we have to achieve in research to show that we do this for the benefit for everybody in the end. So we're running a little bit now. We have some couple of minutes left. So we have 8 minutes left. If there were any further questions, so maybe one question concerning the project consortium. So you met once a year, more or less, and did you use? And this is more a personal question. How did you exchange? I mean, we are all talking about home office and video conferencing. I mean, that project started in 2013. I guess you used all of these tools everybody fancies right now for a long, long time already. So I guess video conferencing is nothing new for you at all because you worked across 15 different countries. I mean, how did you organize that exchange except writing emails? I guess you did use all the tools.
Okay.
And, well, is there something you would recommend from your side using that tool? How did you stay in contact? How did you, the annual meeting was just one meeting, but how did you manage the interaction between these meetings?
As you could, what you see here was just, let's say, the really top level view. Aflonex in itself, we had these 4 techno pillars were organized in 5 technical work packages. Each work package was consisting of several, let's say, sub-work packages, and then you have a work package leader. So you have, on the one hand, to meet the complete consortium was twice a year. The annual review meeting was always together with the European Union, with representatives from the European Union. Then we had an intermediate, every 6 months we had as well a meeting with let's say internally, only on high level, but of course there were meetings on working level regularly. And about communication, of course, we had as well a weekly meeting, a weekly video conference, a WebEx meeting. We used WebEx at this time. And my recommendation is you could do a lot of video conferencing, but first you have to build a little bit of trust in each other. And I think trust you can only build in a personal relationship. And therefore, we did in the beginning a lot of personal meetings in parallel besides these video conferences in order.
The microphone was off, Martin. Somehow we lost.
My system is a little bit frozen. My video picture is frozen. So I don't know what you did. You hear my answer? I think not at all. Huh?
Yes. The last question, the last sentence we didn't get.
Okay, so I think you have to. We did in the beginning. We really did a lot of physical meetings in order to, let's say, what I call a little bit of bonding people together, to create trust, that people trust in each other, and then video conferencing is not a problem at all. And of course, we had a weekly WebEx conference. And there's one proposal or one recommendation I always like to give it on the hardware side. It's first, please check if all people can join such a video conference, because we had some obstacles as well, that some partners were not allowed to use these kind of systems. Then they had to connect via their private computer and so on. And I think this is the preparation before you start a project is really stakeholder management, not only technical, but as well, let's say, from the infrastructure, what are people willing to do, what are they able to do? And I think this is really my strong recommendation when you set up. During the project lifetime, there is, if you trust in each other, I think this is a key word for me. This is really trust and respect. If this can be given, and you always have to be transparent as project leader, no hidden agendas, no not playing games, just be transparent, be clear, and then people trust, and then you can do this kind of collaboration with 40 partners successfully.
Yeah, thank you, Martin. Good final remarks. I would really underline that this is really key. And I think this is what ICAS is for as well, to meet, to exchange, to build trust across nations, across institutions. And I already see here in the Zoom conference, Carl Van Vesten from Boeing. So welcome. You don't see him yet, but I do see him. So I have one Airbus guy and one Boeing guy here on the screen. This is already building trust, building collaboration, building friendships. And it's really a shame that we couldn't be in Shanghai all together, having a beer together. This is really what you meant, Martin, at the beginning, to build trust, to meet each other, and then continue with video conferencing. And this is, I think, the ICAS spirit, and this is why the von Karman Award is well earned on your side, because this is exactly what the von Karman Award is about: international collaboration, trust, projects, working together, and this is what ICAS is about. So this is really a great example of that, and I hope to see you then in person. And now I would like to hand over to Axel or to the tech team to then transfer us to the closing ceremony. I think we have 1 minute left or something. I don't know how the tech works with that. But I would like to close this session. Thank you again, Martin. Thanks you again. Congratulations to the team for the well-earned reward. And I would like to hand over now to the team again. Thank you, Martin.
Thanks a lot, Roland.
Bye-bye.
Bye-bye.